Very good morning. In today's video, we are going to discuss another concept of neural network, that is ADALINE, adaptive linear neuron. See, in our previous video, we have discussed Perceptron, and this is basically one of the advanced concept of Perceptron, you can say. It was developed by Woodrow and Hoff in 1960. And the basic important points in this specific network is it uses bipolar activation function, that is the value will be in between 1 and -1. It uses delta rule. See, delta rule is very important in that case. What delta rule is, it is basically, you can say, the mean square error, that is basically the difference between the actual output and the desired or target output. See, ADALINE works on supervised network. So in supervised network, you all know we have some training set. So we will have some set of inputs as well as a desired output that we wish that our network should fulfill or follow. Right. So whenever we will get some input, means the summed input, you can say, that summed input or the output that our network is giving to us, that will be compared with the target output that we are willing to have. Okay. If our the difference between them, or we can say the error that we will calculate in that case is minimum or up to the tolerance, then we will say, yeah, the network is working properly. Otherwise, we have to train it more till we are not getting the minimized error. Okay, so it uses the mean squared error for that one. Weights and bias that we are using in this specific network are adjustable. We can change them accordingly. Okay, if we talk about architecture, see, the architecture is very similar to perceptron network. We have these inputs over here, and then every input is associated with some weight. We have a bias that is having some value 1 specifically. So what this network is doing, it is basically calculating the sum of all inputs multiplied by their weights. So if this is x1, it is w1, this will be x1 w1 plus x2 w2 plus x3 w3 plus xn wn, and it will get the whole sum of that one associated with a bias that is b multiplied by its value. Okay. Then finally, with respect to perceptron, we can say we are having an additional thing over here, that is extra feedback loop that basically compare or basically use for calculating the error over here. Okay, so it is comparing the output that this network is giving to us after getting the summed output of that one, that will be compared with the desired output. Okay, so we will get that value, and accordingly we will update the weight if it is not as per the tolerance. Right, let's see the learning algorithm of that one. So first of all, the weights and bias are set to some random values. They will not be 0, except 0 they will have some random value. We will set the learning rate. In this case, that learning rate is alpha, that is being mentioned over here. We will set some value for this also, and then we will calculate the net input to the output unit. Okay, that will be x1w1 plus x2w2 plus x3w3 plus x4w4 plus xnwn, and bias will be added with that one. So it will be b plus summation of I equal to 1 to n xiwi. I will be from 1 to n. Okay, so we will get yn, or we can say that is the cost function, or we can say that is the net output that we are getting in that case. Sorry, net input that we are getting in that case. So yn we will calculate accordingly using this formula. And then we will have to update the weight, and we will have to calculate the error. How we are going to update the weight is, we are getting this. We already have wi old that we have already set it. As we are saying that we initially we will set weight and bias with some initial values. And alpha is also set some parameter values. So wi old is already being set it. Okay, that is some initial value of wi old, plus alpha is the learning rate that we are giving. T minus yn, t is the target value that we are willing to have at this point, minus yn is the net output, net input. Okay, it will be multiplied with the value of xi. So the formula is wi new. If I is 1 in this case, then w1 new will be w1 old plus alpha t minus the net input calculated into x1. For x2, w2 new will be w2 old plus alpha t minus net input multiplied by x2. For bias, we are not multiplying with any x1, x2, because its value for bias value, it will always be 1. So in that case, we are not multiplying it with any other specific constant value or variable value, you can say. Okay, so bias new will be bias old plus alpha t minus yn only. So accordingly, we have updated the weight. We get the new weight for all these specific links, and then for bias also. Okay, then we will calculate error. For error, we are having the formula target minus net input to the power 2. Okay, we'll calculate the square. That's why it is called mean square error. So we are getting mean and then finding the square of that one, and that will be error in that case. Here we have to check if the error generated is less than or equal to the specified tolerance of error. Then in that case, we will stop our algorithm there. This is the stopping condition, you can say. And if it is not, then we will, what we are doing, we are updating the weight accordingly, and then we are again getting the net input. Again, we are checking the error. If it is not, then again we have to update these weights and bias. So we'll keep continuing this step till we are not getting this tolerance. Okay, and once we got the tolerance, we will stop this. Right. So guys, in next video, we are going to discuss a solved example of ADALINE, how it works. With an example, we will see that. So guys, till then, please like and subscribe. Thank you very much.